In a previous video, we saw that when you differentiate x squared, you get 2x. So 2x is the derived function of x squared. It is the derivative. When you differentiate x squared, you get 2x. And you can write it as when y is equal to x squared, then dy by dx is 2x. This is saying the rate at which y is changing with respect to x. And if you have it in the form, the notation f of x equals x squared, then you write f prime x equals 2x. Alright, so that's what we have. When y is equal to x squared, then dy by dx is 2x. So if we have y equal x squared, then dy by dx is equal to 2x. Now, what that means, if you have a point at x equal 1, then the rate at which y is changing with respect to x, when x is equal to 1, dy by dx would be 2 by 1, which is 2. And we saw in a previous video that when you plot x squared and you find the gradient, when x equals 1, the gradient is 2. Alright? So the gradient of our line, let's fix the line so that it becomes a tangent here. Alright? So the gradient of this tangent will be 2. Now, it also means that if you place the point at 0.5, your point is here. When x is equal to 0.5, the gradient of the curve, dy by dx, the gradient of y equals x squared, dy by dx is 2x, which is 2 times 0.5, which is 1. So if we have the tangent here, let's move our tangent. We need to adjust the angle of our tangent line, and we put it here. This is a tangent at x equals 0.5. The gradient of this tangent is 1. Therefore, you can say the gradient of the curve, when x is 0.5, the gradient of the curve is 1. And wherever you put your point, x equals 1.5, the gradient would be 2 times 1.5, which is 3. If you choose x is equal to 2, the gradient of the curve y equals x squared would be 2 times 2, which is 4, and so on and so forth. Alright? So what this does is give you the gradient of the curve at a particular point at x equal whatever point that is. Just multiply it by 2x. Multiply whatever value you choose by 2x. If whatever x is, multiply it by 2 and you get the gradient. Alright? Now, we have looked at y equals x squared, and we found the derivative. We differentiated y equals x squared from first principle. What I want you to do for me is this. I will have the curve y equals x cubed. Good. Let me move this line away and erase this point. This is the curve y equals x cubed. Right? Let me zoom in a bit. What I want you to do for me is this. Differentiate y equal x cubed from first let me rewrite that principles from first principles. Differentiate y equal x cubed from first principles. And then what I want you to do is hence find the gradient of y equal x cubed at x equals 0, x equal -1, and x equal 1. Alright, so I want you to pause the video and go ahead and do that. In fact, I'll end this video here. I want you to do it, and in the next video we'll go through the working. So I will see you